Welcome back. The last class of Mendelian disorders is sex-linked disorders. So for the autosomal disorders, be it recessive or dominant, I've stressed much on do not put the X, Y, and XXS, the sex chromosomes, when you are answering such questions which relate to autosomal dominant and autosomal recessive. But for the sex-linked, since it touches the sex chromosomes, clearly draw the Punnett square, put XY for the male, XX for the female. But we also try to remember, by the time we're introducing the genetic disorders, we said Y do not hold any allele. Anything which touches Y will relate to infertility. So a man, XY, the X will either carry the allele for the disease or will carry allele for healthiness. So it means only the woman has options. It can be carrier, she can be healthy, or she can be affected, correct? But the man is either affected or not. Simple. So let's look at the X-linked. All the X-linked disorders are related much with the sex chromosome. So they're known as the sex-linked disorders. And almost all of them are X-linked recessive. So we don't have example of dominance. The examples which I've given in the table are for recessive. And some, like color blindness, as much as I didn't mention, but they also fall under the class of X-linked recessive. Remember, if we talk about hemophilia, we talk about the color blindness, put the X and Y for the female, for the male, sorry, XX for the female. Then read the statement well, whether the woman was a carrier, whether the male was infected or healthy, put it correctly. So none of the genes is related to Y. When it touches the Y, it brings about infertility. So there is no Y link. Talking about X-linked is you are asked the number of females who are affected, the number of males who are affected, because we have to write the sex chromosomes up there based on the statement whether the female was healthy, the female was a carrier, the female was affected. For the male, it's either the male being healthy or affected. So for the X-linked, you can see the mother will have XX. If it's a carrier, one of the allele for the disease will be on X and the normal one will be on the other X. If the man is unaffected, in the case of a recessive, remember we said for the autosomal recessive, as much as it was touching autosomes, but the allele for the disease is recessive. So in this case, we are specifically giving an example of an X-linked recessive. It means the allele for the disease is recessive. The capital one will stand for the healthiness, but we have to include the sex chromosomes. So the Punnett square helps us. It helps us much to understand all this. So in the case of hemophilia, for example, if you use it here, then the woman will be like this. The woman will show like this. We'll have X, capital H for healthy, X, small h for the disease, that is hemophilia. Meaning The man is X, capital H, and Y. So they have to show like that. This is how this scenario looks like. Then the questions which will follow will be, how many girls are carriers? How many girls are healthy? How many girls are affected? How many boys are affected? How many boys are healthy? Boys can't be carriers because Y is not carrying anything. So what I've said, for you to give me a Punnett square, kindly include the chromosomes. Include the chromosomes. This is male. Now we have put the male down, but don't worry, so that we can understand it. It has to look like that. Then the possibility will be, the possibility here will be X, that is the female who is healthy. I'm giving the example of hemophilia, please. So it will appear like this. This is a healthy girl, unaffected daughter. We have a carrier daughter, as it shows from the statement. This daughter is a carrier. One of them will be a carrier daughter. And then one of the boys is unaffected. This boy is healthy. And one of the boys will get the allele for the disease from the mother, will be sick or will be hemophilic. That is it. So it shows X-linked recessive. It means the allele for the disease. We are talking about hemophilia, that is healthy. I can't write well with this one, but I can try. Healthy. But the small h, hemophilic. The same will apply to color blindness, or for all the X-linked recessive and we'll have the homozygous recessive, the ones who will show that they have the allele for the affected. So we will call them heterozygous. We will not call them healthy because this one relates well with the X-linked. In the dominant one, autosomal dominant, we were saying they were healthy because the allele for the disease was recessive. The dominant allele was healthy. So the heterozygous refer to them as unaffected. But in this case, we have to specify that they are heterozygous, they are affected, or they are healthy. Remember, Y is not touched. Nothing on Y. Only excess will carry the allele for the disease and allele for healthy. So these are the examples of the diseases which are X-linked recessive disorders. Remember, I mentioned color blindness is still in here. It's only that I've not given it. So if you see a condition also talking about the color blindness, it is also sex-linked. And then at that point, it is sex-linked recessive. So you have to give the sex chromosomes, and you also have to read the statement well to know whether the mother was a carrier or the mother was fully affected or the mother was healthy and then the father is either healthy or affected.